Hey guys, it's Matt, welcome to SpeedTutor. So today I'm going to show you how to create a simple first-person controller. I was creating something where you can create the illusion of speed in terms of being able to affect the FOV and do lots of things like that. I will have a tutorial on that, but I actually wanted to make this first. This will incorporate making the first-person controller, which has just got basic functionality for walking, running, footstep sounds. You can do some jumping, control all the inputs and do things like that, because sometimes you just need a character controller that you want just to be able to test something in a scene, to be able to expand on it and do things like that. And I'll put it all on my Patreon for you to be able to check it out, and also 195 other scripts, projects and loads of stuff on there that you can check out too. Do check out all the other links in the description for all the best sales, savings and everything for this month, because there's some insane bundles on Humble Bundle and great sales for the summer Unity sale. And if you do need to know about the character controller from Unity, it's what we're going to use in this tutorial. You can check this page and I'll put it down in the description, and it shows all the built-in methods which we are going to use move and simple move to create this. So really, you want to start off by, I've just got a GameObject, which could be a brand new one, so you could just right click and create empty, and then just make sure you reset its position if you do that. So in my case, I've just named it FPSController, and then I've added a component which is called a character controller. And it's just something that's written by Unity, which allows you to take basic functionality of being able to create a character controller. It allows you to use collisions and all things like that. And you can set things to be able to take into account for slope heights, what the actual center of the object is, what the radius of it is, and the height. And it's good to keep your settings roughly like this and keep your height to about 1.8 meters. And that's just around a generic size that should stick around a 6 foot or 1.8 meter human being. Then you want to make sure that you parent a main camera or just a normal camera to this object. So you can right click again on the hierarchy and choose camera in this case. And make sure you position your character roughly at the top of where the height of your character would be. And make sure it's parented so it always follows your character around. So I'm going to add a new component to the FPSController GameObject and just call this a new script and just name this first person controller. Now we've added that script, I'm going to open up in Visual Studio. So when we're here, I'm going to get rid of the starting methods. So we're going to start off, and I've written just a header for my movement speeds. So we're going to be able to change this and actually create the handling of the movement. So I'm going to start by writing serialized field, private, float, and we're just going to have this as walk speed, and then set that equal to 3. And then you could eventually have something for the sprinting later down the line. We're going to actually create a private reference to the character controller that we're going to use, and Visual Studio in this case creates me just a field name called character controller again with a lowercase, and then we'll create a start method because we want to be able to initialize this. So we can say that character controller equals get component character controller, so it's the one that's on this object. Then we're going to write an update method. Then we're going to write a method called handle movement, because we want to keep that outside of the actual update method so we can keep that nice and clean. Then I'm going to write that method like we just said, so void handle movement. So we'll start by saying that the first one is going to be the vertical speed and set that equal to input.getAxis, and then in quotes we'll type in vertical, and this will use the old input system because I don't really like the new one because it's just not very friendly. And then we can have float and have the next one as horizontal speed, again set that equal to getAxis. And then in quotes, we're just going to name that horizontal, and I'll show you how to find this in Unity so you know the names, and have that times by walk speed 2. Now what I do like to do to make this look neater is at the top I'm going to create a new header which is just for the input customization, and then I'm going to create 2 new serialized fields which is going to be just strings, and it's going to be horizontal move input and vertical move input, and they're just going to be the names rather than specifying them directly in the code, which we can't easily change. If we specify them up here, we can change them in the inspector. So what I'll do is I'll just grab the horizontal, paste it in there, and the vertical move input we'll paste it in here. So then if you go to edit project settings and then you just go to input manager, you can drop down these axes and you can see that horizontal and vertical are already created for the left and right and the up and down directly inside Unity with the older system. So now we've got these two to be able to control what will happen when we use the inputs. Now we need to actually be able to use the horizontal and the vertical speed. So we can start by saying that there's a new vector 3 that we want to create and set that equal to the speed, set that equal to new vector 3, and in this case it already tries to fill in some information that we might want, so I'm just going to use that for now. So first of all, I'm going to need in brackets the horizontal speed, because that will be the x of just left and right. It's trying to assume that we'd need this for vertical, but we don't want to move anywhere in the y direction, so we could just set that to 0, and in this case we actually want this one to be the vertical speed, because this is the z-axis for being going forward or back. So this will actually use, because this is finding the local coordinates of the character at any one time, but we need to be able to make sure that we're always being able to move in a direction that we're looking. So in this case then we're going to say that speed then equals transform.rotation times by the speed, so we can get the character in world space so it's always looking forward when we do the movement. We can then just do a simple method which is already built into the character controller component, but in this case we can use something called simple move, which only needs to take one vector 3, which is often the speed, because it takes into all of the calculations for us, and we can go more advanced to be looking at gravity and things like that when we do jumping, but for this case now, for a basic implementation, because you might not even want to go further after we've implemented looking around with the mouse, you can set that equal to speed and you will be able to walk around. And you can see that I can now move left, right, up and down. Obviously I cannot rotate because that's not something that I can do. So I'm going to create a new header called the look sensitivity, and we're going to have a new serialized field called private float, and have that as a name of mouse sensitivity and set that to 2.0f. Then we'll have another serialized field float, and we can call this up down range, and then we can set that to 80.0f, which means we're going to be able to specify how far up and down we can look, so we can't look all the way around. And so now, because we already had these inputs that we specified before, we're going to follow this similar format. So we're going to just create two new serialized fields, private and then string, and then I'm going to have mouse x input, set that to mouse x, and mouse y, and like I said, you can find that into edit project settings and input manager if you need the name, so you can be able to change that in the inspector. Now I want to create a new method in the update, which is just going to be, so I'm going to call this handle rotation. Then below here, below the movement, I want to write a new method called handle rotation, and now we can write a float again. Then I'm going to call this the mouse x rotation. I'm just going to set that equal to input.getAxis again. I'm going to open up the brackets and set that to mouse x input, and then close the brackets, and I'm going to, in this time, say times the mouse sensitivity. So then we need to actually say the transform.rotate with a capital and be able to set that to 0, mouse x rotation, and set that to 0.2, because this actually rotates around the y-axis but directly between 0 and 1 where we want it to look left or right for the x input that we'll be able to control. Now we're going to create a new private variable which we're just going to use and call this float our vertical rotation. Now back down in handling the rotation, we need to then say that the vertical rotation that we've just created, and then when we use minus equals, it makes sure that up looks up and down looks down, and then we can say that input.getAxis mouse y input, close that up, times that by the mouse sensitivity like before, and then we can set that the vertical rotation is then equal to mathf.clamp, because we want to clamp between that up and down range that we created. Then we'll say between the minus up down range and then up down range in the positive, because as you can see, it will clamp this value between minus 80 and positive 80, so we can never look too far up and down. And then in our case, we need to then specify that we want to create a reference to the main camera. So I'm going to go back up to the top. I'm just going to create another private camera and set this to the main camera. And then in this case, in the start method, I'm just going to say that main camera is equal to camera.main. Now we can create the reference down here and say that main camera.transform.local rotation is equal to quaternion, which is often used for rotations, .euler, if that's how you pronounce it. And then we need to specify the vertical rotation, set that equal to 0, 0. We can go into the game and we can look left and right, up and down, and of course we're limited up and down, so we can't just look all the way up and make our character almost go inside out. So we've got ability to control the basic functionality of a character controller. And just out of randomness, That look sensitivity there has just got like, looks like an infinity sign. I've never seen that before in my life. There we go. Maybe it's an Easter egg. Maybe it's something magical that's happened today. So with this being created, now that might be all that you need to do, and you just have something that can run around, look around, and that's it. And now because we've set the groundwork, we can actually set and control sprinting. What I'm going to do is I'm going to create another input down here and just have square bracket serialized field, private. Then I'm going to have key code, and I'm going to have that as the sprint key, and then set that equal to keycode dot left shift as just the default action that we're going to choose here. And then because we've already set that, we're going to set in our movement speed, we had a space for the sprinting, so we're going to write a serialized field. So we'll call this the sprint multiplier, set that equal to 2.0f, and in this case we're just going to double whatever the walk speed is, just so that we can simulate sprinting. Then in our handle movement, we're going to have a float called the speed multiplier in this case, which is just going to be local. Set that equal to input.getKey. Then we'll say in brackets is the sprint key, because we already set that in the inspector. And then instead of just ending that, we're going to use a question mark, which is a ternary operator, to decide if sprint is true or false. So if we held the sprint key down, it would be true. If we let go of the sprint key, it would be false. So in that case, if it's true, we'll say that the sprint multiplier is what would be chosen, or in the other case it would just be 1, which would mean it would be at the multiplier of 1, so it wouldn't change the value, is then just times these vertical and horizontal speeds by the speed multiplier. So then we actually just literally doubling what they already do based on the input that we've created. So it's a really nice shorthand way to make this work. So now you can see we can hold left shift and I can sprint, or I can walk, and we could do this, and we can just add another piece of functionality to this object. You might want to lock the cursor. So what I'm going to quickly show you is cursor.lockState is equal to cursor_mode.locked, and then cursor.visible is equal to false. So when you're playing your game, you won't actually be able to see the cursor, and it will always be locked to the middle, just in case when you're running around you don't want this to happen. So now you might want to add in the ability to jump. So what I'm going to do is create a new header, which is for literally jumping around. Just going to have another serialized field, have this a new float, and call this the jump force, and set that equal to 5. And then we're going to have another float and call this gravity, and set that to 9.81f, because that is actually a realistic value to what the gravity is like on Earth itself. I'm just going to copy this line for the input for the sprinting, paste that into again, and just call this the jump key, keycode.space. And then we're going to create another private variable, set that equal to a vector 3, and set that equal to our current movement. We can set that to a default of vector 3.0. because we're going to be able to calculate what our current movement is any time when we're going to be jumping in the air. Now in our handle movement method in the vector 3 here, we can just change this from speed. I'm just going to call this horizontal movement to make it be slightly better in the way that it's describing. And then I'm going to change the variable to horizontal movement, and then also have it times by the horizontal movement itself. So now I'm going to create a new method which is called handle gravity and jumping. Then here I'm just going to call that method, and then we're going to say that if the character controller dot is grounded, so that same method which is built in to say is it on the floor at any point, and we'll say that if it is, current movement dot y is equal to minus 0.05f, which is just a value so that we know that the character will stick to the ground and we're not going anywhere. And then we'll say that if input.getKey down, and then in this brackets we're going to say the jump key, and then we're going to say current movement.y is then equal to the jump force that we created as a field above. And then under here we'll have an else statement which will say current movement.y minus equals the gravity times by time.delta time. And then we want to go back to our original handle movement method, and underneath the handle gravity and jumping, because we want to do that before we calculate anything else, then we're going to combine both the horizontal movement and that y direction that we just created. So we'll say that our current movement.x is equal to the horizontal movement.x. And then we need to make sure that current movement.z is then equal to horizontal movement.z. And under here where we had the simple move, Now, in this case, we need to use the one that I mentioned before, which is CharacterController.move, and this lets us control physics in a more precise way. So now we can do current movement times by time.delta and make sure you end that with a semicolon. Now we can still walk around, we can still sprint, and now if we press space, we get jump, and we can actually jump and run around at the same time, and it takes both into account. Now again, you can adjust the gravity, so I put it to around 12 because I like the feeling of it, so it is actually more weighty on the character to bring you down, and of course if you increase the jump force, you can go much higher. So the next thing I'm going to show you is to implement some sound effects for when you're actually sprinting, walking. So we're going to create ourselves a new header for footstep sounds, then we're going to have 4 new private variables, one for an audio source, so I'm going to call that the footstep source, the audio clip, which is going to be an array of footstep sounds that we're going to have, and then the walk step interval and the sprint step interval at 0.5 and 0.3. So we'll set that interval based on if we're walking, we want the footsteps to not be as quickly played as 0.3 as the sprint step. So we're going to create then another variable, which is a private float for the next step time, because we need to calculate the next time we should play the step. And then I might just add one more, which was a private float, which is called the velocity threshold. Set that equal to, say, 2.0f. So this is the threshold that we're going to set that when we reach a specific speed, we're going to be able to cap out and stop the actual footsteps making a noise. So then if we go to our update method and we just call this one, we're going to say this is handle footsteps, and then we're going to go down and I'm going to put this under the handle rotation, so void handle footsteps. So we're going to start by writing a flow of current step interval, set that equal to, in brackets, input dot get key, open brackets, the sprint key. Then we're going to have a question mark for a ternary operator again, and we're going to say that if we're doing it or not doing it, holding the key, we'll do our sprint step interval, or we'll do our walk step interval and have a semicolon there. Then under here, we'll say that if CharacterController dot is grounded, because we need to know that it's on the floor, and so next I want to be able to check if we're actually pressing any inputs or not, because this is just an extra check to make sure that we're doing it correctly. At the top, we'll write a new private field called bool and set that to is moving. Then we can set is moving inside our handle movement, and we're going to set that equal to the inputs that we want to have. So what I'm going to do is actually split this up in case we need to use the inputs and shorthand them in a little bit more of a refined way, rather than me here having to specify the long instance of doing multiple calls of input. So if we drop those two down there for the speeds, we're going to get rid of this and just give this a local variable name. Is set float vertical input, set that equal to, we'll grab this thing here, which is the get axis call here, and then we've got it there. Now instead of that, we can just say that the vertical speed is equal to the vertical input times by the walk speed times by that, and then in this case we'll have horizontal input, set that equal to the one we've got here for the horizontal speed, and make sure that we have that times by the horizontal input times by that. So now in this case we can set is moving to the vertical input is not equal to, so exclamation mark equals 0, or with those two line breaks there, which is next to Z and between shift for me, then we can do between the horizontal input is not equal to 0, so we can check if there's any input going on or not. So down again in our footstep handling, because we just did that as an additional check, back down here, and is moving, and time.time is greater than next step time, and CharacterController dot velocity dot magnitude is greater than velocity threshold, like we had before. And we can say that we're going to play the footsteps, and then we'll say that the next step time is equal to time.time plus the current step interval, just so that we can make sure that it plays after the last one if that's what we've worked out. So then under here, we can have the method called void footstep sounds, and we're going to start by saying that we're having an integer of a random index, because we might want to randomize between several different footsteps that we have rather than ever having the same. If footstep sounds dot length is ever equal to 1, that means if you only ever applied 1 to that field, random index is equal to 0. So it would only play the sound which is available in the array, just so that you couldn't get any errors. Now, in any other case, we want to actually say that the random index is equal to random.range. So we can choose between all the ones in the actual array we've got, between 0, which is the start of the array, and the footstep sounds.length, which is the end of the array, and then -1. So we always subtract 1 to avoid using the last one in the actual array. Then we can say that if random index is greater than or equal to, and we need a new private variable up here, which is private integer last played index. And we'll set that equal to -1 just because that we never want it to be something that we've ever played before. So we can go back down to the random index, set that equal to if the random index is greater than the last played index, then we'll do random index ++. And then what we'll do is we'll say last played index is equal to the random index in this case. Then we'll set the footstep source.clip to the footstep sounds, and then in that case it will autofill to put the random index inside those square brackets. Then we'll say that the footstep source dot play will play the audio on there. So now we can minimize this, and on our FPS controller what I'm going to do is add a brand new audio source to that. And now you can add this to the empty slot here, and you can see here that we've got an array for the amount of footsteps we might have. So I've got a whole selection here, so I'm just going to add each of them to my array. And now because I've done that, you can set the actual walk step interval if you want to change it, and also increase the velocity threshold because we actually want it to cut out so it doesn't play an extra step if it takes a little bit of time for the character to actually slow down from accelerating after it's sprinted or walked, for instance. One thing I forgot to mention in my script, if we go back to the handle footsteps method, we just need to call the play footsteps here, add a semicolon, and then go back in. Now when we're in Unity, we'll be able to hear this. And then you could hear the actual footsteps sound when we were sprinted, but I always recommend to actually turn down the volume of the audio source. So if you do ever have footsteps in your game, make them really quiet, like a 0.1 or 0.05, just to make sure they're only a very subtle background noise. But as I say, this is just the combination of everything together. So this includes moving, rotating, jumping, sprinting, and sound effects, and being able to randomize that so you never get the old sound effect in itself. And of course, you'll be able to get this all on my Patreon, along with all the other 195 different scripts, assets, and projects you cannot find anywhere else. Do let me know if you want to see another video with more customizations to this. Do be sure to check out all the links in the description for Unity Summer Sale, all the best savings, and the massive great stuff on Humble Bundle, because I've made some videos on some insane bundles that are over $2,000 worth of assets for 30, and it's absolutely madness. I'll put all the links down in the description. Special thank you to Peter Steiner, Mike Cullen, Thanchu, and Isidora Negri for their amazing support, and thank you so much for everybody else for coming to watch. Don't forget to like, comment, and subscribe. Cheers.